English as a math speech. We will cover the basic concepts of geometry that are essential for understanding and mastering the material, through explanations of fundamental geometric terms and axioms, as well as discussions on the relationships between lines, planes, and angles. Students will gain a solid foundation for further study of geometry. Table of content. 1. Dictionary of mathematical terms. 2. Introduction to basic concepts. 3. Axioms of geometry. 4. Relationships between lines, planes, and angles. 5. Geometric figures. 6. Geometric solids. Dictionary of basic terms. Point, line, and plane are basic elements of geometry. Point. The basic element of geometry has no dimensions, only position. It's marked with capital letters. Example, A, B, C, P, or T. Line. The basic element of geometry that is undefined. It is determined by any 2 points. It is denoted by lowercase letters. Example, A, B, C, or T. Ray. A part of a line that starts at a point and extends infinitely in one direction. Line segment. A part of a line between 2 endpoints including them, as you can see on the slide. Plane. The basic element of geometry that is undefined. It is marked with Greek alphabet. Plane in the space can be defined with 3 not collinear points that lay on that plane, with line and point that is not on the line that lay on that plane, and with 2 lines that lie on the same plane. Angle. Part of the plane formed by 2 rays that share a common endpoint. Quadrilateral. A part of a plane bounded by 4 line segments, a polygon with 4 sides. Rectangle. A quadrilateral with 4 equal angles. Square. A rectangle with 4 equal length sides. A parallelogram. A parallelogram is a quadrilateral with opposite sides parallel. Triangle. A triangle is a polygon with 3 sides. Triangle types considering the sides. 1. Isosceles triangle. 2. Equilateral triangle. 3. Scaling triangle. Triangle types considering the angles. First, right angle triangle. Second, acute triangle. Third, obtuse triangle. Perpendicular bisector of a side. The perpendicular bisector of a side of a triangle is a line that is perpendicular to that side and passes through its midpoint. Medians of a triangle. Medians are the lines that connect each vertex of the triangle to the midpoint of the opposite side. Intersection of the perpendicular bisectors of the sides. Intersection of the perpendicular bisectors of the angle. Centroid. Orthocenter. Circumference. A circle is the set of all points in the plane that are equidistant from a given point. Circle. A circle is a part of a plane bounded by a circumference, including the circumference itself. Parts of a circle. Diameter, radius, sector, chord, segment, tangent, arc, circumference. The introduction to basic concepts of geometry. Geometry is a branch of mathematics that deals with the study of shapes, sizes, positions, and the relationships between spatial objects. Understanding the basic concepts of geometry is essential for successfully mastering the material and developing mathematical thinking. The fundamental concepts in geometry that are used but not defined are the point, line, and plane. These concepts are the foundation upon which the entire theory of geometry is built. Instead of definitions, their properties are described by axioms, statements that are not proven but accepted as true without proof. Axioms express fundamental facts that are foundation upon which geometry is built. classical axioms of geometry, established by Euclid, form the classical axioms of geometry, established by Euclid, form the foundation of what we call Euclidean geometry. Euclidean axioms. First postulate, axiom of a line. Through any two distinct points, exactly one line can be drawn. Second postulate, a line can be extended infinitely in both directions. Third postulate, a circle can be drawn around any point with any radius. Fourth postulate, all right angles are equal to each other. Fifth postulate, axiom of parallel lines. Through a point not on a line, exactly one line can be drawn parallel to that line. David Hilbert introduced a more precise and formal set of axioms to clarify some concepts that Euclid did not explicitly define. Hilbert's axioms are divided into 5 groups. Hilbert's axioms. Axioms of incidence. Two distinct points determine exactly one line. Every line contains at least 2 points. There are at least 3 points that are not collinear, not all on the same line. Axioms of order. If point B is between points A and C, then all 3 points must be on the same line. For any 2 points, there is at least 1/3 point that lies between them. Axioms of congruence. If 2 segments coincide, then they are equal. If 2 angles are congruent, then they are equal. Axioms of parallelism. This axiom is similar to Euclid's 5th postulate about parallel lines. Axioms of continuity. There are geometric objects that satisfy the properties of infinity, such as infinitely extendable lines or circles. These axioms provide a foundation for reasoning and proofs in geometry. They enable logical reasoning in geometry and serve as the basis upon which more complex theorems and rules are built. Relations between lines, planes, and angles. In geometry, we study the relationships between lines, planes, and angles. Some of the key concepts we will cover here include parallel lines. 2 lines are parallel if they never intersect, no matter how far they are extended. Skew lines. 2 lines in space are said to be skew if they do not intersect and there is no plane that contains both lines. Intersecting lines. 2 lines intersect at exactly 1 point. Angle between lines and a plane. The angle between 2 lines can be acute, right, or obtuse, while the angle between a line and a plane is defined as the angle between the line and its projection onto the plane. Angle between 2 planes. If planes pi and ρ intersect along line P, then through point A element of P, a unique perpendicular A contained in pi and a unique perpendicular B contained in ρ pass perpendicularly to the line P. The smaller of the angles formed by these 2 perpendiculars is the angle between planes pi and ρ. Geometric shapes. Geometric shapes are 2-dimensional figures that occupy a specific area in a plane and are defined by their edges, angles, and vertices. The basic geometric shapes include triangles, quadrilaterals, and circles. Geometric shapes, such as triangles, quadrilaterals, and circles, are fundamental elements in geometry. Understanding their types and properties is crucial for successfully solving geometric tasks and problems. Each shape has specific characteristics that can be studied through its angles, sides, areas, and other important elements, providing deeper insights into the structure and relationships among geometric objects. Triangle. A triangle is a geometric shape with 3 sides, 3 angles, and 3 vertices. It is the simplest polygon. The sum of the internal angles of a triangle always equals 180 degrees. Types of triangles based on side lengths. Equilateral triangle. All 3 sides are equal, and all internal angles measure 60 degrees. Isosceles triangle. 2 sides are of equal length, and the angles opposite those sides are equal. Scalene triangle. All 3 sides have different lengths, and the angles are also different. Types of triangles based on angle sizes. Right triangle. It has 1 right angle, 90 degrees, and the other 2 angles are acute. The longest side in a right triangle is called the hypotenuse. Acute triangle. all angles are less than 90 degrees. Obtuse triangle. One angle is greater than 90 degrees, while the other two angles are acute, less than 90 degrees. Properties of triangles. Sum of internal angles. The sum of all internal angles in a triangle always equals 180 degrees. Perimeter. The sum of the lengths of all three sides. Area. The area can be calculated using the formula area equals 1/2 times A times V, where A is the length of a side of the triangle and V is the height dropped to that side. Quadrilateral. A quadrilateral or four-sided polygon is a geometric shape with four sides, four angles, and four vertices. The sum of the internal angles of a quadrilateral always equals 360 degrees. Types of quadrilaterals. Square. All angles are right angles, 90 degrees, and all four sides are of equal length. Rectangle. All angles are right angles, but the sides can be different lengths. Opposite sides are equal. Rhombus. All four sides are of equal length, but the angles are not necessarily right angles. Opposite angles are equal. The diagonals of a rhombus are also the angles bisectors of its interior angles and are perpendicular to each other. Parallelogram. Opposite sides are parallel and of equal length. Opposite angles are equal. Trapezoid or trapezium. It has one pair of parallel sides. If both pairs of sides are parallel, the trapezoid becomes an isosceles trapezoid. Kite. It has two pairs of adjacent sides of equal length, and one pair of opposite angles is equal. Properties of quadrilaterals. Sum of internal angles always equals 360 degrees. Perimeter. The sum of all side lengths. Area. For specific quadrilaterals, the area is calculated using the appropriate formulas. For example, for rectangle, the area is calculated as area equals A times B, where A and B are the lengths of the sides. Circle. A circle is a geometric shape in which all points in the plane are equidistant from the center. The distance is called the radius of the circle. Properties of a circle. Circumference of a circle. The circumference perimeter of a circle is calculated using the formula C equals 2 times pi times r, where r is the radius. Area of a circle. The area of a circle is calculated using the formula A equals r squared times pi, where r is the radius. Diameter. The diameter of a circle is twice the radius, that is, d equals 2 times r. Tangent. A line that touches the circle at exactly one point is called a tangent. Parts of a circle. Semicircle. A shape bounded by a half a circle and a diameter. Circular sector. A portion of a circle bounded by two radii and the corresponding arc. Circular segment. A portion of a circle bounded by a chord and the corresponding arc. A circle is the set of all points in a plane that are equidistant from a fixed point called the center. The distance from the center to any point on the circle is called a radius. A circle is a line. It is just the boundary, so it has no area. A circle does not have an interior region. It is merely the circumference. A circle includes the entire area within the circumference. Thus, a circle consists of all points inside the circumference, including the circumference itself. A circle has an area that is calculated using the formula A equals pi times r squared, where r is the radius. A circle is the area bounded by the circumference, not just the boundary itself. Therefore, while the circumference is just the edge, the boundary, the circle encompasses the entire area within that boundary. Geometric solids. By learning the fundamental concepts of geometry, axioms, and the relationships between lines and planes, we establish a solid foundation for understanding more complex geometric concepts. Considering geometric solids and their properties allows us to apply this knowledge more easily to everyday problems and situations. Geometric solids can be divided into polyhedra, or convex solids, and curved solids. Polyhedra have flat faces and edges, while curved solids have curved surfaces. Convex solids include prisms and pyramids, whereas curved solids include cylinders, cones, and spheres. Cube. Volume, surface area, face diagonal, space diagonal. Regular tetrahedron. Volume, surface area. Cylinder. A three-dimensional geometric solid with two parallel circular bases and a curved surface. Volume, surface area. Cone. The base is a circle and it has a curved surface that tapers to a point. The slant height of a cone is the length that connects the vertex of the cone to any point on the edge of its circular base. The slant height is denoted by the letter L. The slant height of a cone can be mathematically calculated using the Pythagorean theorem, utilizing the radius of the base r and the height of the cone h. The formula is cone, volume, surface area. We hope this video will help you with your learning.